Good day, welcome to One-on-One Maths Private Tutors. Today we are looking at this topic, loci or locus. Locus is the singular. Loci is the plural, which means many locus. So let's define locus. The locus of a point is the path or region that the point covers as it moves according to a particular rule. The plural of locus is loci. The locus of points that are a fixed distance from a given point is a circle centered at the given point. What do we mean by that? If the rule says we have a point and we want to find the set of points that are 3 centimeters from, let's call this point A, from point A. Everything that is 3 centimeters from point A is the locus because it's following this rule that there are 3 centimeters from point A. So all these points define a circle. Anything that is 3 centimeters, if this is 3 centimeters from there, 3 centimeters, 3 centimeters, everything that is 3 centimeters from A. When we join all these points, they define a circle. So the set of points that are 3 centimeters from A is a circle with a radius 3 centimeters. So how do we do that? We take our ruler, our compass, we measure 3 centimeters from a point A. Let's call this point A. We can construct all the points that are 3 centimeters from A. So this will be a circle. We can say this circle is a set of points that are 3 centimeters from A. Any point on this circle is 3 centimeters from A. So we can say all these points are equidistant from point A, and they define a circle. Okay, equidistance, which means equal distance from A, which is 3 centimeters from A. This means that the locus of a point 3 centimeters from A is a circle. The locus is a set of points or region that follow a particular rule. In this case, it's a set of points. The locus of a point less than 3 centimeters from A is the region inside the circle. If we are to find the set of points that are less than 3 centimeters, anything inside the circle is less than 3 centimeters. The locus of a point greater than 3 centimeters from A is the region outside the circle. Anything outside the circle, if we pick a point out here, its distance from A is greater than 3 centimeters. It is more than 3 centimeters. 3 centimeters is up to this circle. Anything outside, we can shade. Okay. Anything outside is a set of points that are greater than 3 centimeters from a point A. Now, let's look at a line. We've done a point. Let's look at a line. The locus of points that are a fixed distance from a given line is a pair of parallel lines. So we want points that are an equal distance or that are equidistant from our line. If we have a line and we want a set of points that are 2 centimeters from this line, how do we do it? We take our compass, measure 2 centimeters, 2 centimeters, go to our line, draw a circle, go to the end of the line with our compass, draw a circle, then join the extremes, the top parts of our circle, join the bottom part. Now we know these two parallel lines are the same distance. If we are to drop a perpendicular there, this distance from here to there is 2 centimeters. From here to there is 2 centimeters. So our original line AB, we want to find the set of points that are an equal distance or that are equidistant from AB is this line and that line. The locus of a point 2 centimeters from a straight line is a pair of lines parallel to that line, 2 centimeters away from it on either side. So this is the locus, this is the given line. The locus of a point equidistant from 2 intersecting lines is a pair of lines that bisect the angle between the lines. So if we are given 2 intersecting lines and we want to find the locus of points that are equidistant from these lines, the set of points that are an equal distance from these lines, we bisect the angles. How do we do that? We need a compass and a ruler. We can bisect these lines. Let's put our first arc here. Then we move our compass here and our compass there. Okay, so we have bisected this angle. Let's use a different color. Let's bisect this angle. We need to increase a little bit. Take our ruler. We bisect this angle. The locus of a point equidistant from 2 intersecting lines is a pair of lines that bisect the angle between the lines. So the angle between our lines is this, and that. Those are the angles between our given lines in red. And this is the set of points that are equidistant from these lines. Right. What does that mean? If we are to drop a perpendicular to that line and drop a perpendicular to that line, we'll find that this distance is equal to that one. So they are an equal distance. This is the locus in green. If we drop a perpendicular from any point on the locus to the given lines, the distance will be equal. This distance is equal to that. All right, let's look at an example. Draw a triangle ABC with sides AB 5 centimeters, AC 4 centimeters, and angle A 50 degrees. Okay, let's draw the triangle. So first we want AB, which is 5 centimeters for our baseline. Draw our line, mark point A, then take our compass, measure 5 centimeters, go to point A and mark off point B at 5 centimeters. Okay, that is our point B. AC is 4 centimeters. Take our compass, measure 4 centimeters, go to A, make an arc of 4 centimeters. Angle A is 50. Take our protractor, measure an angle of 50 degrees from A. 50 degrees is here. So now we take our ruler and connect. So there is our point C intersecting with this line, the 50-degree line, the AC. So there is our C intersecting with 4 centimeters curve and the 50-degree angle at A. We join B to C. There is our triangle. Add the locus of the points inside the triangle that are nearer to AB than AC. So AB is a line, AC is this line. So we want points that are nearer to this line than this line. So what we need to do is to bisect this angle so that we get the set of points that are equidistant from AC and AB. So what we want to construct is an angle bisector there so that we get this line, which is an equal distance from AB and AC. Then we can shade this part which is closer to AB than AC. Okay, so how do we do it? We need a compass to bisect our angle. So we take our compass to A, a compass point to A, mark an arc on AC and AB. Then take our compass again to the points there, mark an arc, go to the other point, mark an arc. Then we join that new point to A. Then we bisect that angle. We want points inside the triangle that are closer to AB than AC. So it's all these points. Everything below this line, this bisector, is closer to AB than AC, and it's inside the triangle. So that's what we have. That is the solution. Let's look at this question. Construct the triangle ABC with angle A equal to 30 degrees, angle B equal to 50 degrees, and AB 10 centimeters. So we need a starting line first. So we take our ruler, draw our baseline, AB, set our starting point there. That's our A. Then measure 10 centimeters to B. AB is 10 centimeters. Now let's take our compass, measure 10 centimeters. So this is B. Now we need our protractor to measure the angle at A. Our protractor at A, we measure 30 degrees. Here is our 30-degree point. Angle at B is 50. We go to B. Our protractor. We use the inner scale now because this one is starting from 0. So 50 is there. Mark our 50-degree point. We then join these 2 points using a ruler. Join the 50-degree point to B and the 30-degree point to A. Then we join this 30-degree from A. So this is our point C. Construct the locus of the points equidistant from A and B. A and B are points. So the set of points that are equidistant from A and B is a perpendicular bisector. A and B also forms a straight line. This is a line. So the set of points that are in equal distance from these points is the bisector. So what do? We construct a perpendicular bisector. We take our compass to B, make a generous arc. We take our compass to A, also make sure the arcs intersect. We take our compass to A and draw an arc. Where the 2 arcs intersect, those are the points we join to form our perpendicular bisector. Then we join the 2 points where the arcs meet. Now let's use a different color. So any point along this line is an equal distance from B and A. What are we saying? If we choose a point on the perpendicular bisector, connect it to A, and then connect that point to B. This point is an equal distance from B and from A, which means this line is equal to that line. So a perpendicular bisector makes a set of points that are an equal distance from the end points of that line. Thank you.